Apparently, 8-bit is no longer enough to store my subscriber count. Hello all and welcome back to the corner. In today's video it's going to be a lot more relaxed as I want to celebrate reaching 256 subscribers, or rather 270 at the time of this recording. I'm only a little bit behind schedule there. First of all, I want to thank you all for the tremendous amount of support that you've all given me. It's been a real motivating factor for me to keep continuing to make videos. And with the new year ahead of us, I can only hope that I can keep making entertaining videos for you all. So with this milestone reached and a new year at hand, I thought it might be a good idea to look at some of the past things that I've done, including before making videos. As one of my interests is within electronics, I thought about diving into some old PCBs and electronic designs that I've worked on as a bit of a fun topic to discuss. So I want to talk about why I made them, what they did, and how I do them differently now. Now I'll try to have chapters in the description or off to the side if you want to skip ahead to certain boards or skip past one that I'm currently showing. I'll also be trying to do them in chronological order, but some things might appear out of orders, and as my subjects of interest tend to be the same kind of things, you might see some repeats, so I apologise up front for that. Anyway, I think we should start with the first board that I actually made. Now this isn't much, in fact it's a mess of electronics on, I don't even know what you call that nowadays, I'm not sure what you'd call that kind of variable, is it variboard? Anyway, and you've got some block connectors up front. You'll see there's red, black, which is power ground, H, L, E, B, 1 and 2. So what this is, well, other than my first board, is actually I used to have a 1999 Ford Fiesta. It was one of my first cars, and I would modify it to have certain other features, such as I remember putting lights on the inside that faded in and out when you open and close the doors, including what I called submarine lighting. So on the inside, this is actually from a Ford Mondeo, but in the inside of it there was a button for the boot, and you'd press it, the boot would open, everyone's happy. As the car never came equipped with a electric boot popper from the factory, what I instead did was got this board to control it. And the reason was I didn't want the boot button to operate if the handbrake wasn't enabled or the engine was running. And this sounds like weird requirements, but there's a lot of context that goes into this. Basically, there was a center console. They didn't usually have this one. I put in from a Ford Focus Mark 1.5 or mid facelift, and it had two cup holders right at the front, side by side, and I had the boot button right in the middle. So if we were going down a drive-through or something like that, that being me and my friends, and one of us put a drink in the car, it was quite likely we might actually hit the button. So I made this just to prevent that. It was a bit overkill really, I didn't really need to do that. You see, you might be able to see if I get up in here, it's just 74 series logic. There was a small 7805 regulator, yeah, somewhere there's a 7805 in there. And this 7414, which I think is a hex inverter, and then you got 7408, which I think was an AND gate. Or maybe it was a quad AND gate. So yeah, that was overkill, really, for the purpose, but it worked. I built it, it worked, and it was very, very reliable. Of course, then I changed the car, so I just ripped this out and kept it. Sorry, just noticed that the lens is a bit dirty on camera. Alright, let's have a look. What else do we have in here? Perhaps one of the next things I want to show, one of my next firsts, is this. This is actually the first PCB I had made. This was manufactured by Seed Studio. This was just PCBs, they were never actually assembled. I was going to assemble them, but I ended up never doing that. What this was is, my friend at the time had a Nissan Micra K11, 98 vintage I think, and he'd imported some mirrors from I think Taiwan or Japan, which were electrically folding mirrors, and he wanted a system whereby you only had to press a button to fold them or unfold them, and it would keep track of the state, and also when you lock the car it would also fold and unfold them. So that's what this was. This is a little PCB that I think used an AT Tiny, that was it, AT Tiny 84, and it would keep track of the state of the mirrors and then use the 2 relays on board to control them. And the reason there are 2 relays is because there are 2 lines that went to the mirrors. They were usually grounded, but you'd put 12 volts power onto one if you wanted it to unfold, and then flip it around if you wanted it to fold. You didn't need this in order to prevent it from just keep constantly moving in and out, because the mirrors had limit switches in them, so when they got to a certain point they'd just stop. This was literally just to control it for when the car was locked or when you turned it on. These were never built because there's a bit of a bad story behind the mirrors, and they ended up being sold, or not stolen, but one thing that stuck out with me with this board, so this is the input power line for the relays, and you see it's running quite close to those pads. It wasn't that bad, but I was still learning how to use Caustic Eagle at the time. The biggest problem was that I made with it is that this had a big chunky diode for the input protection, because if you in a car, if you put the battery on backwards, then you'd obviously create a negative 12 volt situation across these boards. So that diode was to prevent reverse polarity. And I put a 5 amp diode because I thought to myself, well, this is going to have 2 relays on board. Those relays need to hold about was it 2-3 amps of current, or control 2-3 amps of current. So I put in a 5 amp diode, thinking to myself, I've got more than enough prevention. And really speaking, you might be able to see it if I bring it back up close again. You see there, it goes up to the diode there, and then goes off into this regulator here. That was a 78L05. And on the back of the board, like we saw before, the 12 volt input goes into the anode of the diode and then goes off to the relays. So this board, I didn't need to put in a big 5 amp diode. I could have put in a regular diode in there, but there wasn't much wrong with it. It just never ended up getting used, so I don't know how well it would have worked, to be honest with you. Probably as good as my programming, which at the time was not brilliant. This kind of has some bad memories along with it as well. This is actually a board that has a dual relay on it, another AT Tiny 45 if I remember rightly. Some will be a 78L05. Not much else going on about it. This was actually harvested from a control unit from the car. This was actually requested by my then boss, who used a Mitsubishi Evo 2, was it Evo 3, Group N rally car. And he had set up on the front of it, where the intercooler was, a little spray nozzle for spraying water over to the intercooler to help with efficiency. And he asked me if it was possible, whenever he let off the throttle, that whether the board could automatically activate the washer pump so that it could spray water onto the thing as he let off the throttle. I said yeah, that wasn't a problem. So I made this board, designed it, and it seemed to work fine. I could probably use a 555 timer, but I ended up not bothering, because I think I tried 555 timer at the start of it. It worked, but not super reliably, and then I just decided, you know, I'm spending more time and effort, I may as well just stick an AT Tiny on there and just reprogram it if there is something wrong. So yeah, nothing particularly wrong with that again, but never got used. Anyway, so that's that. I think I kept that because I left the job and this was still in my parts drawer. I thought to myself, well, I made it, I'm going to keep it. Alright, this is another little board that I made. You can obviously see I've started populating it, but I think I've actually stolen components off of this over the years, which is quite a common occurrence with my boards, really. So about the same time when I was making that previous board that we just saw for the Mitsubishi Evo, I was making a Hackintosh computer out of a old G4 computer where the CPU pins on the socket got broken. So I was converting it to use micro ATX motherboards. But I remember specifically saying to one of my friends at the time, I still want it to make that McChime sound. Not just make the McChime sound, but have it configurable. So I wanted a way to have it, when you plugged in the PC and turned it on, that this board would automatically play the chime, and then you could use the interrupt button on the front of the G4 to change the sound effect. So I started making this. This is using an Atmega 328PU chip, which is the same as using an Arduino Uno. There would be a micro SD card slot for the samples. This here, in fact, I'll just give you a whole overview of the board here. So that was the amplifier chip. It was a National Semiconductor amplifier, and that was just basically a board that actually came from one of the Dell Optiplexes, little speakers inside of them. They're very useful for that. And this worked. It works on the motherboard that I was going to use. I plugged this in and it did actually make sound, and the way that this worked is the Arduino would read the wave file from the SD card, and then it would use PWM modulation to make, I think it was like a 1-bit square wave audio output, and then that would get amplified for this chip. So not very high fidelity, but good enough for what I wanted to do. Oh, and that was it. This would also fade the power LED. So on the G4, when you turn on the machine, it didn't just turn on the LED would actually fade in, and then it would, when you're going on into sleep mode or something like that, it would fade out. So this board also did that. I remember getting most of the way through, and then the motherboard I was using died, and I thought, okay, it's not too bad, I'll just change it out. I changed it out and then plugged this into another motherboard, and that motherboard would turn on and then fail to work. I plugged this into the motherboard, put the power into the power supply, it would immediately turn on the PC and then just hang. And that's when I realised, because I designed this board for that original motherboard, I designed it for how it was wired up. PC panel pins, the power switch pins, one was ground and then one was signal, and then that would switch the signal to ground. And that was fine for this board because that's how this board was set up. It would just ground that pin there. The board that I went to use with the Macintosh, or the Hackintosh, it was backwards. It would actually use the pin 1, which is ground on the other board, to turn on, and you'd actually have to bridge across a 5-volt signal to it or something crazy like that. So basically I realised that this board actually wouldn't work with, I think it was something stupid, like 70% of my motherboards at the time it wouldn't actually work with. It would only work properly with that first one, and I was really annoyed by that because it was only going to work with a handful of PC motherboards at the best of times. Was also more annoyed because I got really into the project, so much so that I think there's what, 10 boards I was going to make, something like that. All of these are basically junk. They don't work. Well, they won't work on most things, and like I even put a nice little logo on there. So that was a bit of a failure, but I learned, and what I did was I was making a revision B of the board, which would actually use sensing on both pins and try to figure out which machine that you're using, and it started getting overly complicated, and I probably will revisit this at some point because I still have the Hackintosh. It's only off to the side, to be honest with you. So there you go. That was, I think this was actually McChime or McChime version B. Right, let me start off with this mess. This is obviously an Arduino shield. This goes onto an Uno. There's a dip switch, has a hardwired cable. For some reason, a hardwired cable goes into pin headers. I'm not sure why I did that. That's the glue looks awful. And goes into, I want to say, a DA15 connector female. What it went to was probably my favourite board I've ever made. Was this. Now there's quite a bit going on here. So you've got 3 big 7-segment displays, smaller 4-segment, 2 17-segment displays, 2 bar graphs at the top, more connectors, 2 buttons, and actually what's missing off of this board, oh yeah, look at all that wiring. There's actually supposed to be a piezo speaker there, which, strange enough, I've harvested over the years. A bit of context, remember the story with my friend with the K11 Micro, the one that we made these boards for. And if you don't know what I'm talking about, go back to the chapter where I talk about it. One of the things that we wanted to do, we wanted to make a digital dashboard for it. So LED displays for speed, tachometer, fuel and everything like that. I can't actually remember the reason that we wanted to do it, other than the fact that it just seemed like a cool idea. We talked about it, we decided what we wanted to do was have big displays up front for your speed. This would have gone up to, well, I mean, it would have gone up to 255 kilometers an hour, or whatever that is in miles per hour, because I've actually forgotten. The reason I said 255 kilometers is just that was just the largest number that you could fit in an 8-bit variable. We decided we wanted 4 segments for the tacho, and the reason that we wanted 7 segments, because one was for coolant temperature and one was for fuel level. So I think the fuel level was read in percentage, and then this one was actually read out in Celsius. The reason we wanted 7 segments because at some point we decided we wanted to see words being written across this. So when you turned the Arduino that ran this on, it would actually put Micro K11 on these and scroll it past. These would have been for resetting that was it as well, because we wanted those, but if you press one of these buttons, it would actually flip these to show menus, trip counters and stuff like that. And one was for resetting the trip counter. And the reason we have the bar graphs at the top, we decided it seemed like a fun idea at the time to have the indicators be actual scrolling indicators. I can't remember if we're going to have them with overlays that had an arrow, so that the actual arrow would scroll over. We went really into this wanting to do a very nice job of it. In fact, this was really complicated because at the time I didn't know about Charlie plexing, and I still kind of don't understand it. I mean, I do, but the way this works, if I go to the back, and yes, there's a mess of wires going everywhere. There's a 16-bit bus that runs on this, and then the cathodes of all the different displays were actually connected to another 8-bit bus, and those would connect down into these chips here. See if we can focus on some of these. We got a CD4017, I can't remember what that one was. Well, that chip, which is covered by 3 bodge resistors, I mean the whole board is bodgy, but there we go. Got 74595, that is a 8-bit shift serial in parallel shift out register. CD4021, that was a shift register for inputs. I think that's because we wanted to have that be extra inputs going in. And then this chip in the bottom here is a CD4050, which is a inverting buffer, I think. So that was probably another 74595 thinking about it. So I would have had 16 bits there, and I would have had, no, maybe that's what that was. Maybe that was actually you'd have a counter here. So you start on the first display of the speed, then it would shift over, then it would do this one, these two, then that.
Editing me here, and that was about the poorest explanation I could have possibly given you. Let me over how this worked and why I did it like this again. Firstly, if we go back to that diagram, this is how the board is logically wired up. Here is the 74595 chips and the CD4017 counter chip. Here are the 4 7-segment LED displays, which for argument's sake we'll call the engine speed readout. Here are the 2 bar graphs for the indicators. And finally, here's a 17-segment LED display, of which there are 4 on the original board. All of the displays used are common cathode. This means that all LEDs have their cathode joined to one pin, like soldering 2 LED cathode legs together. All of the anodes are separate inputs to actually control which segment lights up. In this circuit, all similar anodes are joined together, so A to A, B to B, C to C, etc., into a 16-bit light bus, which then goes to the 74595s. If all the cathodes were connected to ground, this would mean that all displays would light up, which would cause all displays to show the same or garbage data and also draw too much current from the logic chips. As such, we also need to control which display receives ground reference on its cathode pin. This is where the counter comes in, as it sequences which display is being activated. So to display a number on the 7-segment RPM display, the Arduino would firstly send the data to the shift registers serially. Once all the data was in the shift register, it would then latch the data to the outputs. Thus we see 1 and 2 on the respective displays. It would then load in the data for the next 2 displays and then latch this to the outputs. The 4017 counter is clocked on every subsequent latch event so that it moves to the next display, so now the 3rd and 4th displays show the numbers 4 and 8. The indicators are done in the same way to create the scrolling effect. So far, realistically, there was no need to use more than 8 bits, as no display actually uses more than 8 inputs, so using a 16-bit bus seems a bit superfluous. And honestly, it is. But, now we move on to the 17-segment display. This has 17 segments that can be controlled, which is more than twice what the other displays need, with one being an input for the decimal point, which was never actually used. But the problem is, it only has one cathode pin, so I couldn't split the display to use 2 cycles for displaying the data, as I needed to present all 16 bits of information at once. This was always going to need some extra decoding to run, and in the end, using a 16-bit bus instead of an 8-bit bus actually greatly simplified adding these alphanumeric displays, as I only needed to add one more 74595 and a lot more wires. So in the end, the display would use the bus and the counter to sequentially display all the LEDs like this. And using a high refresh rate and persistence of vision to make it appear as though they were lit all the time.
I realised there was a problem when I first turned this on. It's because it would display just complete garbage until I reset the Arduino. And that's because I never had this board sync up with the Arduino, at least not originally. You see that, I think it was that bodge resistor I put in that did that. It would, I then wired that to the DA15 connector so that there was a reset line. So every time the Arduino booted, it would reboot this or reset that counter chip so the Arduino was in sync with which display it was displaying. This took me so long to design and make, and like I said, remains one of my favourite pieces, even though there's not much I can do. I mean, being a display, I could make it do anything I wanted to now, but I just haven't found a use for it. Maybe I should make a subscribe account or something like that in future. I don't know. Ideas for future. But yeah, one of my favourite boards. So I think that was the last of the micro stuff.
And with that, I think it's about time that we finished up this video. I apologise for the sudden end, but this video is already very long. In any case, I hope this video came across as interesting, or perhaps that you learned something. I'm hoping to design some new ideas this year, and I'd love to bring you along with me. So please let me know in the comments if this has been something that you've enjoyed. And once again, thank you to all my current and future subscribers, and I'll see you again next time.